So write this problem as homework. If matrix A1 is small a1, matrix A2 is A2, A3, A4, A5, matrix A3, A6, A7, A8, A9, A10, A11, A12, A13, A14, and this keeps on going up. Okay, and An is n cross n square matrix, right? Like this, it will keep on going. A1 is 1 cross 1, A2 is 2 cross 2, A3 is 3 cross 3, and the numbers inside are in like going on like that. Now, what is small ar? Small ar is given as step of log r base 2, where this is GIF. It's not a matrix. Array element is a fixed value. What I want is find trace of TR, trace of A10. Try this problem. We'll discuss in tomorrow or tomorrow's. Either tomorrow's class or day after tomorrow also. Write it down, please. Let's start with determinants. Now, if you have a determinant, let's say A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. You are introduced to determinant with this. Correct, students? A 3 cross 3 determinant or a 2 cross 2 determinant. You are introduced to determinant using this. One is Kramer's rule. 10th standard में जो linear equation को solve करने के लिए था. This is the place you were introduced to determinants. Second was when you learned cross product between vectors. Third, when you learned area formula in coordinate geometry. Till now, so far, where and all we use determinant. And collinearity condition. 3 lines collinear, sorry, not collinear, sorry. Concurrency condition. 3 lines concurrency. Fifth one is pair of lines ka condition. You know, delta equal to 0. It's also a determinant. Yes or no? These are the places we learned, where we use determinants. Okay. Upcoming chapters, matrices and vectors and 3D में और ज़्यादा use करेंगे determinants. So in this determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3, if you observe this, like you know how to open the determinant, right? Yes or no? Let me give you a recap of that. Generally, you open determinant like this. You write plus, minus, plus on the top, and you take the first element. When you take the first element, what you will do is, you will close this row, close this column, and you write A1 into B2, B3, C2, C3. Then what will you do is, you'll remove this, and first row is anyhow, it is always there. Then you'll close second column, and write minus A2, minus के साथ A2 लेना है, into B1, B3, C1, C3. Then you will take plus A3 into B1, B2, C1, C2. You're going to write this. Yes or no? Students?
Yes.
And one part I want to teach you here, tell you here. The first part I want to tell you here is, this is the usual way of expanding the determinant, but we don't need to follow this all the time. We can open with any row or any column. We need not open with first row only. See, this is actually opening of the determinant with respect to first row. We can open with any row or any column. Just that you have to be writing this plus minus plus is there now. You have to continue that. Plus minus plus आ गया. Plus के बाद minus आएगा. Plus minus. Minus के बाद plus आएगा. Minus plus. Just write it down. Once you write it down, let me open the same determinant with third column. I can open with any row, any column. Okay, I'm just picking you the third column. If third column I pick, I'm going to write what? First element is plus A3 into close the row in which it is there. What will I get? 4 elements. B1, B2 hai. And when you write B1, B2, don't write plus minus. We'll write it as it is. Plus minus is only for the numbers that are outside. B1, B2, C1, C2. Then we'll write it. We'll close the second row. Minus B3 into B1, B2, C1, sorry, A1, A2, C1, C2. Correct? Next, we'll close this one. Plus C3 into A1, A2, B1, B2. This is your answer. This is the opening of determinant with respect to third column. Is it clear, students? Any doubt? Students, is it clear? Now I'll ask somebody. Siddhant, are you there?
Yes, sir.
Can you open this determinant with respect to this row? Can you tell me what I should write first? पहले क्या लिखना है?
B1 into.
No, not B1. पहले B1 के ऊपर माइनस है, माइनस B1 into लिखना है. Is it clear?
Yes, sir.
So minus B1 into close this row, and what will you write?
A2 C2 and E3 C3.
Okay, first tell the row. Okay, read horizontally first. Next we'll close the second one. Then what will you write?
Plus B2.
Plus B2, correct?
A1 A3 C1 C3.
Perfect. Next, we'll close
Minus,
the third row.
Minus B3
Minus,
A1 A2 C1 C2.
Perfect. Samjha, students?
Yes, sir.
And generally, this is the thing that I tell you. Like, this is not a rule or such. One suggestion I give you is try to make a habit of opening the determinant with respect to row or column in which at least 1 0 is present. Is it clear, students?
Yes.
क्योंकि कोई एक रो में मान लो 2 zeros है, मान लो ये दोनों zeros हैं. Okay, in this I'm writing AB 0 है, AB 0 मान लो. Expanding with respect to this column is very easy, right? क्योंकि इसमें B2 C2 आता है, B2 into एक determinant आता है, C2 into एक determinant आता है, दोनों zeros हैं. You don't need to do. Just A2 वाला determinant लेना है बस. समझा ना students? Minus A2 वाला. Is it clear, students?
Yes, sir.
Yes, sir.
Right. Find value of 1 3 2 2 minus 1 1 0 1 5. Find students. Can I ask you to open in some way? Okay, open with first column. That's better. Open with first column quickly. It has 1 0, right? और third row से भी open कर सकते हो. Doesn't matter. Open with first column. So what do you do, students? First,
minus 32.
plus minus plus, correct na? Answer minus 32, correct. So first you will write plus 1 into close this row, close this column, minus 1 1 1 5 minus 2, that is the second one. Then close this. You will write 3215. And next is 0. We don't need to write. 0 into, it will be 0 only. So this will be minus 5 minus 1. Minus 6. 15 minus 2. 13. 13 2s are 26. Answer is minus 32. Did you get the answer, students?
Yes.
Please write it down. Saris expansion. What is Saris expansion? Saris expansion. See, generally this is another way of expansion. Saris is a mathematician. So in this process, how we are going to apply now? See, majority of the students love to expand the determinant like this. Initially it looks confusing, but it is not. Like afterwards, once you use some 5 times, after that it is never confusing. You will expand it much faster and better. Even in classes also, I will try to show you how do I use my Saris expansion. So for example, AE determinant लेते हैं, इसका expansion दिखाता हूँ, Saris expansion. Oh, I can expand, I can improve it, right? Fine, not a problem. Okay, listen to this. So one thing that we know about this, which is the principal diagonal. This is the principal diagonal, students.
Yes.
This is the principal diagonal. Multiply the numbers along the principal diagonal. 1 minus 1, 5. What is the multiplication, students?
minus 5.
Minus 5. Next, multiply numbers along the principal diagonal parallel to it. Matlab, these two I have to multiply along with this number. See, not the number beside it. See, हर बार हम 3 numbers को multiply करेंगे. Okay? 3 and 1 को multiply करना है इस तरफ वाला corner वाला number से. 3 1 0 का multiplication क्या है? 0. Then 2 1 को किससे multiply करना है? ये वाले number से. 2. Correct? So principal diagonal के along 2 parallel diagonals. Next,
4 no?
opposite of principal diagonal. Opposite of principal diagonal is this one. When you multiply these, write with a negative sign. Multiplication of 2 and minus 1 is what? Minus 2. ये आएगा, sorry, 2 and minus 1 into 0. 0, so minus 0 लिखो. मतलब जो भी आंसर आता है उसको माइनस से मल्टीप्लाई करके लिखना है.
सर वो मल्टीप्लिकेशन में 4 आएगा ना?
Oh, sorry. 2 2 Thank you. 2 2 4. My mistake. 2 1 0 2 2. Correct. Next, ये वाला मल्टीप्लिकेशन 1 into 1 into 1. 1 आ रहा है -1. ये वाला मल्टीप्लिकेशन क्या है? 3 2 6 6 5 30. -30. Is it clear? So आंसर क्या है? यही डिटरमिनेंट का एक्सपेंशन. 3 प्लस वाला प्रोडक्ट, 3 नेगेटिव वाला प्रोडक्ट्स. So आंसर क्या आ रहा है? This will be 36 minus 36 plus 4 minus 32. Is it clear? Students, is it clear? Imagine,
Yes, sir.
imagine you have a symmetric determinant. See, this is the standard determinant. Standard determinant 1. See, there are some 5-6 standard determinants which I ask you to remember. Remember the result. मतलब जब भी वो determinant आपको दिखता है, answer you have to write down सीधा. You don't have to do any calculations or anything. This is one of them. Standard determinant. A B C B C A C A B. Now let us expand this using Saris expansion. Okay, पहले हम क्या करना है? Principal diagonal, right? So multiplication of these three is what, students? ABC or ACB? Multiplication of these three. Can ABC? Multiplication of these three. These two into this. ABC. Then principal diagonal का multiplication हो गया. We'll do the opposite. Opposite with negative sign, right? So this is what C into C into C. C cube. But we'll write minus C cube. Next. A into A into A. A cube. Minus A cube. B into B into B. Minus B cube. So इसका standard result is 3ABC minus A cube minus B cube minus C cube. You need to remember the result for us. Standard determinant one. See, please write down the explanation in your own words. Okay, how do we open using Sarah's expansion? Write in your own words. But trust me, after opening the determinant like this in 5-6 methods, sorry, 5-6 problems, then you'll never use the original approach. Okay, write down. If omega is cube root of unity, complex cube root of unity, unity means 1, right? Find 1 omega omega square 1 omega square 1 omega. Right. So we can do this very easily. You can use standard determinant 1 per result, or you can use Sarah's expansion also. What is this? This is omega cube. Even omega into 1 into omega square, that is also omega cube. Omega into 1 into omega square, that is also omega cube. Minus omega raised to 6. Omega square into omega square into omega square. Minus 1 into 1 into 1, minus 1. Minus omega into omega into omega, omega cube. And we know omega cube is 1. 1 plus 1, omega raised to 6 is also 1. This will be 0. Because it's a cube root of unity, the cube will be 1. Any doubt in the students?
No, sir.
Please write it down. And write the heading, properties of determinant. Now, property 1. If all elements in a row or column in a determinant are zeros, then value of determinant is also 0. Of course, this makes sense. Why? If you look at it, if I write zeros in one of the rows or column, let's say A1, B1, A2, B2, A3, B3 is there. Or row also, it doesn't matter. I will expand with respect to this row. If I expand with respect to this row, what will happen? I'll get 0 into 4, 0 into other 4, 0 into other 4 will come. Of course, value is 0, right? Yes or no, students?
Yes, sir.
Students, any?
No, sir.
Now, property.
Yes, sir.
Property 2. If 2 rows or 2 columns of a determinant are equal, then value of determinant is 0. Of course, this also makes sense. imagine if I write A1, B2, A2, A2, B1, B2, B2, C1, C2, C2. Now I'll expand with respect to this column. What will I get? I will write plus minus plus and open accordingly. That is A1 into B2, B2, C2, C2, correct? Minus B1 into A2, A2, C2, C2 plus C1 into A2, A2, B2, B2. Now when I open this, what will happen? Ab dekho, B2, C2 minus B2, C2. Value will be 0. A2, C2 minus A2, C2. Value will be 0. A2, B2 minus A2, B2. So value is 0, right? If two rows or two columns are equal, then value of the determinant is 0. Is it clear, students? Students, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Write it down. Third property. Det of A equal to det of A transpose. Even this makes sense if you observe what happens when you do transpose. Imagine A1, A2, A3, B1, B2, B3, C1, C2, C3 is there. What is the transpose of the matrix? If this is the A matrix, a transpose of this will be, we will write A1, A2, A3 in column, B1, B2, B3 in column, C1, C2, C3 in column. So determinant of both the things will be same. Why? आप इसमें फर्स्ट रो से एक्सपैंड करो, इसमें फर्स्ट कॉलम से एक्सपैंड करो, you will be writing exactly same calculation. Check karo. Here you will write plus minus plus, here also you will write plus minus plus and expand. A1 के साथ में क्या लिखोगे? B2 B3 C2 C3. इधर भी A1 के साथ में B2 B3 इधर आएगा, C2 C3 इधर आएगा, but still the value is going to be same. B2 C3 minus B3 C2. Is it clear, students?
Yes, sir.
Yes or no?
Yes, sir.
So the calculation is going to turn to same, and opening with respect to first row and opening with respect to first column, they are going to be equal in expansion, and so these two are equal. Any doubt in the students? Students, any doubt? Now fourth property. What is fourth property is, if A and B are square matrices, in fact ABC are square matrices, all of them are square matrices, then det of AB is equal to det of A into det of B. I can write this for 3 and 4 also, provided they are square matrices. So det of A, B, C, I can also write as det of A into det of B and det of C. See, all of you know that determinant is defined only for square matrices, not for any other type of matrices. Rectangular matrices, it is not defined. So, but we know AB can be, see, AB can be a square matrix even though A and B are not square matrices. Correct now, students?
Yes.
करेक्ट ना?
Yes.
एक 2 क्रॉस 3 को 3 क्रॉस 2 से मल्टीप्लाई करने से स्क्वायर मैट्रिक्स ही मिलता है. At that time, right hand side is not defined. So for this to be equal, then A and B should be of square matrices. Write it down, students. Property 5. If two rows or two columns are interchanged, then value of determinant will be negative of original determinant. Listen to this. If two rows or two columns are interchanged, I'll show you in 2 cross 2 also. Imagine you have A1, A2, B1, B2. Iska answer is what? We know A1, B2 minus A2, B1. If I interchange first two columns, मतलब A2, A1 लिखता हूँ, B2, B1 लिखता हूँ. I just interchange these two columns. Then what will come? A2, B1 minus A1, B2. This is like negative of the original, right? Correct now?
Yes.
And this is going to happen for 3 cross 3 also. You can look at 3 cross 2 also. Imagine if I write A1, B1, C1, A2, B2, C2, A3, B3, C3. Now when I interchange two rows or two columns, I'll interchange these two rows. Okay, what will happen? This is going to turn to first row, we kept it same. Second row and third row we interchanged. Correct? Students, yes or no?
Yes, sir.
Yes.
Now when I expand it, what am I going to get? Here plus A1 plus minus plus A1 into B2 C2 B3 C3 आता है. But इधर क्या आएगा? Plus A1 into B3 C3 B2 C2. उसके वजह से things are going to be negative of original. Yes or no? Why? ये दोनों को observe करो. First row and second row has been interchanged. We just proved that in the 2 cross 2. Interchange हुआ तो negative आएंगे. Correct? So this will be minus of the second row. Any doubt in the students? So whenever you change two rows, if you have to equate that to next step, आप minus से multiply करना चाहिए. Otherwise they won't be equal. Is it clear, students?
Yes.
Right now. Property 6. If a scalar is multiplied to a determinant, then it will be multiplied to one row or one column only. Matlab it can be any row, any column, but only one of them, not both. For example, I'll just show you. Imagine you have to multiply 2 to A, B, C, D. Okay, 2 is being multiplied. Scalar means a number. Okay, some number we are multiplying to the determinant A, B, C, D. See, you know, if I multiply you to a matrix, what will we do? We will multiply to each and every element. Yes or no, students? Correct?
Yes, sir.
कोई भी नंबर एक मैट्रिक्स को मल्टीप्लाई करेंगे 3 cross 3, 2 cross 2, 3 cross 2, it doesn't matter. If we will multiply to each and every element. Same goes for common लेते वक्त भी. अब 2 common लेना है बाहर मैट्रिक्स से, हर एक एलिमेंट से लेना चाहिए. So एक ही 2 बाहर आएगा. करेक्ट ना? Students, correct?
Yes.
Yes, sir.
So now if we see this, 2 is being multiplied. You can multiply to first row, 2A, 2B, and rest of the elements as it is. Or you can multiply to second row, or you can multiply to first column, or you can multiply to the second column. Is it clear?
Yes.
Any doubt in this? Right.
No, sir.
Now, for this property only, imagine if you have 2A, 2B, 2C, 2D. That means by mistake, imagine you multiply to every element. What would have occurred is, see, we know iska value, right? Iska value is what, students? 2 times AD minus BC. 2 बाहर ही रखो, एक्सपेंड करो, AD minus BC आएगा. ओके, ना इसका आंसर क्या आता है? देखो, मल्टीप्लाई दिस टू और मल्टीप्लाई दिस टू. 4 AD minus 4 BC, correct? 2 2s are 4, so 4 times R. So this is definitely wrong. You understand, right? Like original determinant से जो भी आंसर है वो गलत, इससे मैच नहीं होता है. Now one thing I want to tell you is, imagine if you look at the property reverse. Property reverse देखना मतलब, if you multiply with a number, you multiply to one row or column. Reverse is, if you take common, you should take common from only one row or one column. So इससे 2 common लेता हूं, A B 2C 2D. इससे common लेता हूं 4 A B C D. Is it clear, students? Now the value matched, right? You understand, right? What is coming out? Correct now? So this is what is the basis for the property 7. Property 7 says that if A is a square matrix, determinant of lambda A, and lambda is scalar. Lambda is not a matrix, it's a scalar. That will be equal to lambda raised to n into det A, where n is order of A. मतलब A में कितने रोज होंगे उतने लैम्डास बाहर आएंगे. Of course that is true. इसमें 2 ही रोज हैं, सो 2 बार हमने 2 कॉमन लिया, करेक्ट ना? Imagine you have 4 different rows. Shall I explain you this property again? See, lambda A is what? We are multiplying lambda to a matrix A. So lambda to A1, A2, A3, B1, B2, B3, C1, C2, C3. लेफ्ट हैंड साइड में क्या हो रहा है? लैम्डा एक मैट्रिक्स को मल्टीप्लाई हो रहा है, उसको डिटरमिनेंट लगा रहे हैं हम, करेक्ट ना? सो लैम्डा मैट्रिक्स को मल्टीप्लाई होगा तो क्या होता है? लैम्डा A1, लैम्डा A2, लैम्डा A3, लैम्डा B1, लैम्डा B2, लैम्डा B3, लैम्डा C1, लैम्डा C2, लैम्डा C3. अभी क्या करना है? हर एक रो से एक लैम्डा बाहर लेना है. क्या आएगा? लैम्डा बाहर, लैम्डा बाहर, लैम्डा बाहर, लैम्डा क्यूब. A1, A2, A3, B1, B2, B3, C1, C2, C3. So कितने रोज होंगे उतने लैम्डास बाहर आएंगे. So if A is a n cross n matrix, then lambda raised to n will come. Clear? This is most done mistakes by students. Shall I tell you? They forget when they are doing the calculation. Imagine वैसा रहा, okay? 2AB रहा वैसा. So they quickly write 2 into determinant of A into determinant of B, which is wrong. Do you understand, students? You need to know
Yes.
order of the matrix. Accordingly, you should take it out. Clear? Right now. Try this. A square AB AC, AB B square BC, AC BC C square. Find the value of this. Right. You take A common from this row, B common from this row, and C common from this row. What will happen? ABC will come out. What will be on the first row? A, B, C. Second row से B गया, A, B, C. Third row से C गया, A, B, C. See, all 3 rows are same. Determinant value is what? Any 2 rows are same, then also it is 0. Here all 3 rows are same. Determinant value will be 0. Is it clear?
Yes.
Yes.
Now, property, I think 7 हो गया, 8. Write it down, that one. Property 8. Property 8 says that 2 3 cross 3 determinants can be added or subtracted if two of its rows or two columns of them are same. Let me explain. So when you do matrix addition, what will we do? Imagine you have to add 1, 2, 3, 1, 1, 1, 0, 1, 1, 1, 2. We are adding with 1, 2, 1, 6, 7, 5, 4, 1, 2. What will happen? We will add this element with this element 2. 2 plus 2, 4. 3 plus 1, 4. 1 plus 6, 7. 0 plus 7, 7. 1 plus 5, 6. 5, 2, 4. यही आता है. But determinants cannot be added this way. Two determinants can be added provided two rows or two columns are same. Otherwise, we cannot add them. You just have to find their values and add the values. Nothing other, no other way. You cannot combine to form a determinant. Is it clear? Now, how do I form a determinant? Let me show you one. This thing. A1, B1. Sorry. A1, A2, A3. B1, B2, B3. And C1, C2, C3 is there. We are adding it to D1, D2, D3. B1, B2, B3. C1, C2, C3. What will come? See, second row and third row will be same. B1, B2, B3. C1, C2, C3 will be same. In the first row, what will come? We will get A1 plus D1, A2 plus D2, and A3 plus D3. Do you understand this? We have to maintain two rows or two columns same. Then respective elements of the third row or third column, whichever is left out, they will be added. Else, the addition is not possible. You cannot combine two determinants. Is it clear, students?
Yes.
Let me prove this. Proving is very simple. आप expand करो, proof हो जाएगा. If you expand plus minus plus, plus minus plus, plus minus plus. Now A1 के साथ क्या आता है? A1 के साथ we will get B2, B3, C2, C3. इधर D1 के साथ क्या आता है? B2, B3, C2, C3. Addition of these two is what? Let's say we are adding these two. Addition of these two will be A1 plus D1 into B2, B3, C2, C3. Exactly what we are going to get here. Students, yes or no? If
Yes.
you write, if you would have written 2B1, 2B2, 2B3, then this would have been wrong. Yes or no? Because we are not getting addition of these two. And similar thing is going to happen to other elements also. Second element in this is minus A2. Minus A2 into B1, B3, C1, C3. Either minus D2 into B1, B3, C1, C3. Either क्या आएगा second element? Minus of A2 plus D2 into B1, B3, C1, C3. In this plus A3 into B1, B2, C1, C2 plus D3 into B1, B2, C1, C2. Here plus A3 plus D3 into B1, B2, C1, C2. Is it clear, students, how they are being added?
Yes.
Yes? Write it down. Actually, you need to write this question also, right? Yeah, write this. Now let's relook this property once again for us. Think of it, we are thinking reverse. Matlab from RHS to LHS we are thinking. But from RHS to LHS we are thinking. What is happening? If we have to split a determinant into addition of two determinants, we can split only one row or column by maintaining other two same. Correct ना students? आप इस तरफ सोचो, आप एक ही रो को ब्रेक कर सकते हैं, बाकी दोनों को सेम मेंटेन करना है. Correct? That is the thing. If we have to split a matrix, sorry, a determinant into addition or subtraction of two determinants we have to maintain two rows or columns same. Is it clear? So
Yes, sir.
let me show you through an example. You'll get it much more clear. Okay. Prove determinant of a plus b, b plus c, c plus a, b plus c, c plus a plus b, c plus a plus b, b plus c as 2 times a b c b c a c a b without expanding. Listen to this. So I'm going to take LHS and I'm going to break it into small determinants and prove that that is equal to 2 times that right hand side one. So observe this. First I'll break first column. While I'm breaking first column, other two I have to maintain same, correct? So how will this will be breaking into? This will be breaking into A, B plus C, C plus A, B, C plus A plus B, C, A plus B, B plus C, plus B, B plus C, C plus A, C, C plus A plus B, A plus B, B plus C. Did you understand the first step, students? We maintained C2 and C3 exactly same. C1 we split into 2. Now what am I going to do? I'm going to break this while maintaining these two same. Okay. So what am I going to get? I'm going to get A, B, C, B, C, A, C plus A plus B, B plus C, plus A, B, C, C, A, B, C plus A plus B, B plus C, plus, did you understand, students? Again, second determinant also I'll break it into two parts. What will I get? B, B, C plus A, C, A plus B, A, sorry, B, C, right? A plus B, B plus C, plus B, C, C plus A, C, A plus B, A, B, B plus C. Correct, students? Now, before we
Yes.
go to the next step, in this two columns are same. Its value should be 0. In a determinant, if two rows or two columns are same, value should be 0. Correct, students? So that entire thing is gone. Now I'm breaking further in rest of them. Rest of them I'm breaking further. First wala will be A, B, C, B, C, A, C, A, B plus. I use this already. Now I'm going to use this. That is A, B, A, B, C, B, C, A, C. In this, these two are same. So value of determinant is what, students? 0. Next one I will split. ACC, BAA, CBB plus ACA, BAB, CBC. In this, these two are same. In this, these two are same. So what will happen to determinant, students? 0, 0. Last wala, I have to split it into two parts. That is BCC, CAA, ABB. Again, in this, these two are same. So determinant is 0. Next, last wala BCA, CAB, ABC. Correct? So all the other things are gone. Two small determinants are left out. We are going to write. We have see first one. I should not touch it. Why? We have to prove that twice this determinant. So इस determinant को मैं modify करने का कोशिश करता हूँ. कैसे? I will interchange this row and this row. क्योंकि पहले रो में मेरे को ABC चाहिए. So उसके लिए दोनों को interchange करूँगा. Interchange करूँगा तो क्या आता है? That is negative of original. Correct, students?
Yes.
Then I have to interchange these two because second row में BCA चाहिए. So if I interchange that, then what will happen? ABC, BCA, CAB. Correct? It 2 times negative will come, right? दो interchanges किया था, दो times negative, that will be plus in between. So twice ABC, BCA, CAB. That's what it is. Clear? In this, we used very less number of properties. What are the properties we used? Splitting is first property. If 2 rows or 2 columns are 0, determinant is 0. Second property. Third property we used is interchanging से एक negative आएगा. हर एक बार interchange करोगे एक negative आएगा. 2 बार किया, so addition हो गया. Clear, students?
Yes.
Students, clear? But if you use more properties now, this is easier than this way. Okay, I did little longer process, but we have to use more properties for that. Please write it down. Next important thing is row or column operations. See, these are the manipulation that we can do by not disturbing the value of the determinant. These are the manipulations we can do to simplify the determinant better. See, not always expanding is the only way to do the question. So and in this chapter, at least most of the time we don't expand see that. We try to simplify it much better and we try to do the calculation. See, row operation mein what we are going to do is we are going to do changes in 1 or 2 rows or 1 or 2 columns. Imagine you have A1, A2, A3, B1, B2, B3, C1, C2, C3. And I'm trying to do a change in first column. Okay, I'm trying to do a change in first column. What is the change I'm doing is column 1, I'm going to write column 1 plus 2021 times column 2 plus e raised to pi times column 3. Imagine I'm writing this. My question is, if I write like this, A1 plus column 1 को column 1 plus इस column को 2021 times से multiply करूंगा, that means 2021 times A2. Second column को I'm going to multiply with e raised to pi, e raised to A3, A2, A3, B1 plus 2021 times B2 plus e raised to times B3, C1 plus 2021 times C2 plus e raised to pi times C3, B2, B3, C2, C3. Imagine if I replace the first column with this column, okay, with this value. Is the determinant value preserved? Preserved matlab, is it equal to this determinant? That is the question. Okay. Remember this, if you maintain the column 1 ka coefficient 1, then yes, it is preserved. The value of the determinant will be same. Matlab, these two determinants are equal. If you want, I can prove that to you. How do? I'm going to break it as, see, these two are maintained same, right? I'm going to break it into 3 determinants. First one is A1, A2, A3, B1, B2, B3, C1, C2, C3. Second one is what? 2021 times A2, A2, A3, 2021 times B2, B2, B3, 2021 times C2, C2, C3, plus e raised to pi times A3, A2, A3, e raised to pi times B3, b to b3 e raised to pi times c3 c to c3. Now think of it, 2021 कॉमन लेता हूं, इससे क्या मिलता है? a2 a3 b2 b3 c2 c3. ये दोनों सेम है. वैल्यू ऑफ द डिटरमिनेंट इज 0. सिमिलरली इससे e raised to pi को निकालो. We can take common from one row, right? The moment I take that, then these two determinants will, these two rows will, columns will be same. Even this is also 0. This is 0, this is 0, and we wrote the same matrix again. Did you understand, students? So by row operation, by maintaining the coefficient of a1, मान लो a1 का coefficient same maintain नहीं रखा, आपको क्या मिलने वाला है? Then we are going to get the lambda times the original determinant we are going to get. Correct, na, students?
Yes, sir.
Yes or no? So, as long as you maintain the coefficient same, the value of the determinant is going to be same. Clear?
Yes.
So, that's what I'm going to write here. In row operation, formula, if coefficient of replaced column is maintained same, maintained 1, then value of determinant is same as original. Clear, students? Students, clear?
Yes, sir.
हम C1 को रिप्लेस कर रहे थे, C1 का कोएफिशिएंट सेम रखना चाहिए, 1 रखना चाहिए, राइट?